Today we are going to see one more important unicast routing protocol, and this unicast routing protocol we are going to call it as an open shortest path first algorithm. This open shortest path algorithm, it is an intra-domain routing protocol similar to your RIP, that is a routing information protocol, whatever were discussed in the earlier classes. So it is similar to your intra-domain routing protocol, but it is based upon the link state routing algorithm. It is based upon the link state routing algorithm. So when we discuss about this open shortest path algorithm, it is necessary for us to know what are the metrics that open shortest path algorithm will work. So therefore, it is necessary for us to know, in order to forward the packet, what are the measurements or what are the information, what are the parameters this open shortest path will consider that has to be measured. So in general, your open shortest path first algorithm, it can reach the destination similar to your RIP protocol. So how it reaches the destination? It is based upon the cost of reaching the destination, which will be calculated from host to host and from one AS to another AS. But what happens is, for allocating the cost for each link based upon the weights, we need to measure the performance matrix of the parameters. So what are the performance matrix of the parameters we need to measure is the throughput we need to measure, the round trip time we need to measure, and also the reliability between the data transmission from source to destination. It has to be known. So these are the performance measurements what we need to know in order to decide the cost of the count. Okay, and one very interesting point in this open shortest path algorithm is that each type of service will have a different weights based upon the type of service what we are allocating or type of service what we are providing from source to destination. The average weighted cost what we are going to calculate for each link, it depends upon the type of services which has been providing for source to destination. So based upon that, we will have a different types of cost will be assigned for each path. Okay, so this is the routing table which we are going to use in the open shortest path first algorithm. So here what we are going to do is the router will create a forwarding table after finding the shortest path tree between the destination to the source by using the Dijistra's algorithm. So what the router will do is the router will find the shortest path tree between the source, that is from itself to the destination, by using the Dijistra's algorithm. Okay, and what it does is it compares the routing table. When you compare it to the routing table of the RIP protocol and your OSPF protocol, both are same. Only there is a difference between your routing protocol which is associated with your RIP protocol and OSPF protocol is the difference in the cost. Okay, so if the half count of your OSPA, it will be same for all the instances from source to destination, and also one more thing you need to remember is that when you create a small AS system, when you create a small that is autonomous system, the amount of traffic which will be holded by that AS system, if it is large means, then that large AS system has to be divided into smaller segment, and each segment we are going to call it as a areas, and each areas can be treated as a independent domain for forwarding this link state routing algorithm. And this type of OSPA system, we are going to use a hierarchical manner of transmitting the data from first level to second level, and from first level to autonomous system to the second level autonomous system. So this is the diagram what we are going to use in order to draw the routing table, which we can able to determine through the use of this OSPF system. And one more thing you need to remember is, so as I said you, if the amount of traffic holded by a particular autonomous system. If it is more means, then we need to divide this, the larger capacity autonomous system or the traffic which is holded by the larger capacity autonomous system into smaller areas, and these areas will be served by different entities of the routing protocol. Okay, so you can see here, and then once you have divided your larger areas into smaller areas, and these smaller areas can be routed, or the smaller area can be given as services by using the link state routing algorithm. So therefore your OSPF system, it uses a autonomous system, and also that autonomous system will be using in terms of hierarchical manner. From the hierarchical manner, the data will be forwarded from a source to destination. Okay, so you can see here the forward table which you are going to use in the case of OSPF system, and how the area will be divided in an autonomous system has been highlighted in the diagram. So the forwarding table of your router 1, router 2 and router 3, depending upon the previous what the network we have taken. So based upon that we have reframed, or we have written this forwarding table. For the router 1, so the destination node is N1. Since for the node N1 we have not connected the router 1 to the destination network N1, so therefore we cannot able to identify which is the next router, but we can make sure that the cost of reaching from router 1 to N1 which is equal to 4. Similarly, for the destination network N2, it is not possible for us to reach directly from router 1 to the N2. Therefore, the next node we have given it as a highlighted, that is not available, and the cost of reaching from N1 to your router 1, that is N2 to router 1, it is 5. Similarly, for the destination node N3, since R1 is connected to R2 and R2 can reach to the network destination network N3, so therefore the cost of reaching the destination via R2 we have highlighted as the 8. The next, similarly for the N4, so the N4 can be reached through the routing, that is the next router R2, so the R1 will communicate the information to R2 and R2 will forward the packet to the destination node, that is N4, with the cost of 12. The same manner we are going to use this for the routing table, that is for the router 2, and similarly for the router 3. And when you come to the areas in the autonomous system, so if the amount of traffic which has been handled by a particular autonomous system, it is more means, then we are going to use a router, and based upon the router we are going to divide the areas into smaller segments. So you can see here the entire autonomous system, it is, if the larger number of density, if the density of the nodes are more in this area means, then we need to do the division operations. So if we do the division operations, then we can minimize the traffic handled by each network within the node. So therefore the entire autonomous system has been divided into 3 segments, the area 1, area 2 and area 0. And these areas are backbone, or in the backbonely connected through the use of the routing technology. So you can see here the area 1, it is having 3 switches, that is a LAN switches, and which is connected to the area broader router, that is a border router we have connected. Similarly the LAN 2, that is the area 2, it is having 2 LAN switches, and which is in turn connected to the WAN network, and which is interface to the surrounding network through the use of the area border router. And similarly the area 0, we have a LAN, and which we have a backbone network which has been connected, and with this area 0 which is in turn connected to the area 1, and which is in turn connected to the area 2. So if the traffic, if it is more in a single autonomous system, so through the use of this area broader routers, we can able to establish the links within the network with smaller areas, so that the amount of data handled by each router can be minimized. So this is how your OSPF algorithm will work for data transmission within the autonomous system. Okay, so the next one is you need to understand what is this link state advertisement. So as I told you, your OSPF system will forward the table based upon the link state algorithm. So therefore it is necessary for us to know what is this link state advertisement. So this link state advertisement will enable each node. So what is the state of the nodes links which is present at a particular autonomous network tree diagram. So based upon the connection or the based upon the available links, this link state advertisement will be updated through the use of the link state database. The link state open first, it is based upon the link state routing algorithm, which requires the router to advertise their state of each links so that we can able to update the advertising information or the links of each routers in the link state database. So through the use of this link state database, we can able to create a network tree, which is through the use of the graph methodology, so that when a node is connected to router and the router which is in turn connected to one more router, it is able for us to identify which are the links are there from each node to the surrounding nodes within the network. This graphical representation which will enable us to represent the real scenario over the world with the different entities in the architecture. Okay, and there are different links we can able to create between the nodes depending upon the type of services what we are going to provide from source to destination, and these different services will be governed by the different cost which is associated with the different paths. So you can see here there are different link state protocols are there. So the first one we call it as which is related to the router link, and the second one we call it as a network link, and the third one we call it as a link to network, and the fourth one is the link to your autonomous system, and the next one we call it as a external to the link. So you can see in the router link we have a point-to-point communication. This between the router and router there is a point-to-point communication, and there is a transient link between the switch and the router, and there is a stubborn link between one more switch to the router. So this is how the router will act upon the connection between the point-to-point networks and between the links within the autonomous system. So the next one we call it as a network link. So if you want to connect two networks, or if you want to connect the two sub areas within the autonomous system means, then we are going to make use of the network link. So you can see here the two routers will advertise their routing information to the designated switch. So this switch will able to identify so which is the destination I need to transfer the data based upon the routing information which has been assigned or which has been advertised by the corresponding routers. And in the third one case you can see the figure number C, summary of link to routers. So each router will advertise their information which is related to the area voice, the information routing information. So during the signaling period of the network phase, each area voice network they will advertise their routing information, so that at each instant of time all the routers will have a routing information about the entire nodes. And the second one is between the link to autonomous system, and you have one external entity link is there, and that external entity link want to know what are the routing information which are associated with the area number 0, that is a sub area within the autonomous system. That is also possible through the use of AS router, and within the area also it is possible for us to update the routing information, and also to the external link also it is possible for us to forward the routing information through the use of external link. You can see here the autonomous router will provide a routing information about the surrounding link, that is the external link to the autonomous system, and the routing information about the autonomous system will be forwarded to the external entity by using the figure number E. So these are the external links what we can able to create to in order to advertise or in order to update the link state database. So the first one is, as I said you, the router link. So router link, what it does is it advertises the existence of the router as a node. Okay. So in addition to giving the address of the another router, so here in this type of advertise can define one or more different types of links that connects the advertising router to the another entities. Okay, so it's not only which will advertise the existence of the router as a node. In addition to this, it gives the addresses of the announcing router if this type of advertisement can define one or more type of links which can be connected for the advertising router to the another entities. And a transient link will announce us a link to a transient network. Okay, so in which a network that is connected to the rest of the network by one or more router, so that we call it as a transient link. And in this type of advertisement we should define the addresses of the transient network and the cost of associated to this routing link we need to advertise. And one more important thing, we are going to create a link in this routing link is a stub link will be created. So what do you mean by stub link? It is an advertisement which is being defined by the address of the network and the cost. So what do you mean by stub link? Stub link, it is nothing but it is a network that is not only for the entire network, it also defines the address of the network and the cost associated to it. And one more thing, one more link we are going to establish in the router link, that we call it as a point-to-point link. We are going to define that point-to-point link as the address of the router at the end of the point-to-point link and the cost to get that link. All this information will be available from the routing link. The second one we call it as a network link. So what do you mean by network link? A network link will advertise the network as a node. A network link will advertise a network as a node, but a network cannot do announcement itself. But a network cannot do announcement by itself. Okay, and one of the router is assigned as a designated router and does the advertisement. So means in the network link, all the router will cannot able to advertise the routing information. Among the router, any one router will be designated as a advertising router. So that designated router will able to pass the routing information within the AS system and to the surrounding AS system. Surrounding AS system, so that we can able to see in the network link. So in addition to this, so the address of the designated route in the type of your LSP, it announces the IP address of all the routers. It announces the IP addresses of all the router, but it will not advertise the cost, because the router announces the cost to the network when it sends a router link advertisement. So this designated node, which is we have made it as responsible for advertising the cost link and also the routing information. Only that node will advertise the information which is related to the surrounding nodes and the routing information, but it does not give the information which is pertaining to the cost of each network. Okay, so the next one is this summary link to AS. So the summary links to the network we are going to see. So in this, what we are going to do is a area border router we are going to use as a advertising entity, so that we can collect all the informations which are connected from the backbone network, and we can make a summary of the links which are available at the backbone network. Okay, and we are going to use this, that is a summary of link to network, in order to store all the informations within the area. To gather all those information in a particular area, we are going to use this summary link to network. The next one is summary link to your autonomous system. Okay, so here what we are going to do is the autonomous router will advertise the summary links from one AS to the backbone area currently in which the autonomous system has been connected. And later what this autonomous system will does is it disseminate all the advertising information which are connected to the backbone network also and to the surrounding network also. So that is the responsibility of the summary link to the autonomous network. And the next one is the external link. So in this external link what it does is the autonomous router will announces the existence of the single network outside the AS to the backbone area that is to be disseminated into the area. So this autonomous router in the external link, it enables us or it make us to know the existence of the single network which is outside the AS, which is connected to the backbone area of our autonomous system. So we are going to use an external link in order to know the backbone area, which is a single network which is connected to the outside of the autonomous system. If you want to know means, then we are going to make use of this external link. Okay, so these are the link state advertisement what we are going to use in the case of OSPF network. The next one, so how exactly then this OSPF network implementation will be done? Okay, so your OSPF implementation, it is implemented as a program in the network layer. This open system path first algorithm will be implemented in the network layer in a program. Okay, so and it uses the services of the IP of the propagation. It uses the services of the IP for the propagation. And we know that an IP datagram that carries the message from the OSPF to set the values of the protocols field like 89. Okay, so means IP datagram which is carrying the information which is related to OSPF message, that will be included a value called as 89 value as a port number. And also this OSPF is a routing protocol which will help the IP to route its datagram inside the AS also. So means what? This OSPF implementation, whatever we are going to do it not only enable us the IP to forward the packet, it also enables the IP to transfer the messages within the autonomous system also. And your OSPF message are encapsulated within the datagram and which has got two versions. This OSPF implementation we are going to implement in the form of two versions, and the first version it is not used to the fullest extent, and the second version we are going to use it. Okay, so the details which is related to your OSPF messages authentication and OSPF algorithm has been highlighted in this diagram. So this is a OSPF message format what we are going to use it. So you can see here the version type, message length, source router IP address, area identification, checksum, authentication type, and authentication we are going to use this. This is a OSPF for common header. Okay, so this header will be used in almost all the messages of your OSPF data transmission. So version, as I told you, there are two types of versions are there in OSPF. One is called as OSPF version 2 and one more we call it as a OSPF version 2. And this message length field, it is of 16 bit. This message field will get me the what is the length of the message that we are transmitting. And the next one is the source router internet protocol address we are going to get from this header, that is from this field. And the next one is area identification. Since the autonomous system has been divided into smaller segments, so the area identification has to be identified. So through the use of area identification field, we can able to identify the segment of the area, and we are going to use this checksum in order to measure or in order to implement flow controller and error control processes for the messages what we are going to type. And the next one is the authentication type. So how best the routers are authenticated. So based upon that, we are going to forward the data. Okay, and the second one is the hello message. So this is the hello message, how we can able to pass from the OSPF messages. Okay, so here you can see here the hello interval, network mask is there, we have a and dead interval is there. Along with that, so we need to transfer the IP address of the destination and the backup board network which is connected to the corresponding IP address we need to transmit. So this is the format what we are going to use for the hello messages. And the next one is we are going to use two important messages for the database description and for the link state request. So this is the message format what you are going to use for the database description, and also this is the link state routing request which is used within the nodes in order to get the link state advertisement from it may be the node information about the node itself or the corresponding nodes which are connected to the network. So in the case of database description, you can see here the link state general header we are going to use along with the message sequence number we will be using. Okay, and whatever the messages we are discussing, that is a link database description and the link state routing request. So all those will work for the type 2 implementation, that is OSPF type 2 implementation will be responsible. And you can see the right part of the slide diagram, we have a link state general header. So in this link state general header, so it is necessary for us to know the link state sequence number. So this by the using this link state sequence number, the autonomous system can able to identify the routing information from one node to another node within the autonomous system. And the next one is the link state update. So if you want to update the links between one network to another network, so the surrounding node will transmit the packets in the form of link state update message. So whenever a node receives this link state update message, it will update the corresponding link details in the corresponding destination nodes. Okay, and the last one is your link state acknowledgement. So once I acknowledge the changes which has been happened in the algorithm or in the routing information, once I update my routing table, I should get an acknowledgement. I should send an acknowledgement to the neighboring node saying that so whatever the links are available within the network, I have updated it as on date, and this is the updation mechanism what I did. We are going to intimate to the neighboring node through the use of this link state acknowledgement messages. Okay. So the next one is one more important algorithm what we are going to study in the unicast routing protocol is, that is a border gateway protocol. Okay, border gateway protocol we are going to use. This is also one of the important unicast routing protocol, so which is used as a inter-domain routing protocol which is used in the internet for the today's also. So we are going to use this border gateway protocol. The version number 4 we are going to use in the internet protocol. Okay, and this broader gateway internet protocol, it is based upon the path vector algorithm. It is based upon the path vector algorithm. So here we have since this, as I told you, the broader gateway protocol, it has been used in the case of internet network. So therefore you can see in the figure, so we have used the 4 autonomous system, the autonomous system 1, 2, 3 and 4, and the corresponding node entities what are there, and the different types of links what are there in the autonomous system has been highlighted in this figure. So how they are going to communicate from one autonomous system to the another autonomous system will be done through the use of this border gateway protocol. Okay. So this is the diagram what we are going to use. Okay. And when it comes to the implementation or the operation of this broader gateway protocol, so it works upon with 2 different entities. It works upon 2 different entities, or it has 2 types of installation variations in the implementation wise. And the first implementation we call it as an external BGP. External BGP implementation we call it as, and one more we call it as a internal BGP. Internal BGP means IBGP we are going to call. So this external BGP, it is in this mechanism each border router, okay, in this each border router will be connected to the external entity. So you can see here the router information, that is a router 5 and the router in the autonomous system 1. So the router 1, they are having a communication between one to another router. Okay, so you can see here the external BGP varies with BGP that allows two physically connected border routers in two different areas to form a pair of external BGP speakers and exchange messages. Okay, so means what? If one autonomous system wants to communicate with another autonomous system, then we are going to use a router, and those routers we are going to call it as a external border gateway protocol. So with the use of these external routers, it is possible for us to do the data transmission from one network to another networks. Whereas the internal BGP protocol, it uses the services of the TCP protocol with a well-known port number, we call it as a 179, but it also creates a session between any possible pair of routers inside the autonomous system. So if you want to do the data transmission within the autonomous system, means that is also possible through the use of this border gateway protocol. So this border gateway protocol we are going to use as an external entity to connect one network to another network, and this internal border gateway protocol, it will be used in order to forward the packets within the network also. So the diagram, the left side of the diagram, it is operations which is related to your external BGP, and the right side of the diagram, which is the operation, both it including the external BGP operations also and the internal BGP operations also. So for the it has to work as an external entity, means the router 1 has to communicate with the router 5 of the another AS system, and also you can see there is one more external entity is there, that is the router 6 and router 2 communication, and one more that is a border router we have, that is nothing but AS4, which is connected to the R4 of the AS1. So these we call it as the external operations, whereas the routing information which is pertaining to R1, R2, R3 and R4 of your AS system, that operations we are going to call it as an internal border gateway protocol. Okay. So we are going to stop it over here only for the today's class. If you have any doubts, means let us have a discussion.